Hello everyone, welcome back. This is Professor Roldan with Explorations in Math, section 6.1, order of operations and combining like terms, which will prepare us to solve equations at the end of 6.1. Okay, we're also going to do 6.3 in this video for the purposes of applying our equations to solve application problems or word problems or real world problems. All right, well, let's do this. So, order of operations, if you recall, is some people know it as please excuse my dear Aunt Sally or PEMDAS. Okay, so we have 4 orders, and I'll call this the last one. Parentheses, exponents, second, multiplication, division, third, and then add, subtract, last. Now these last two orders, the multiplication, division, and the addition and subtraction, they both come in a tie. So you're going to do both of these in order from left to right. Okay? So that's just a quick reminder. So let's go ahead. I'm going to do the evens here. So odds in class, evens in video. Okay. So in this case, we're going to do, so the word evaluate basically means to find the value of the expression for a given variable. Okay? So, in other words, substitute. So here's our expression. Oops. Negative x squared. And this is saying substitute the x with negative 3 and find the value of that. Okay, so we're going to put negative 3 in here, which means that we're going to do negative 3 times negative 3 is positive 9, and then negative times 9 is going to be negative 9. Okay? Number 4, we have a trinomial, polynomial, and so we need to put negative 2 in for the expression. So anytime there's an x, you're going to put parentheses and insert the value that we're trying to get here. Okay, so this is 4, this is a positive 4, and we have 14. Okay? Number 6, we have an x to the third power and our x to the first power. So we have our expression, and we're going to insert the negative 2 in here. And so you can use your calculator or just do this in your head. Negative 2 times negative 2 times negative 2, that is negative 8 minus 8. And that's going to be same signs, guys. You're going to find the sum of a and 8 is just 16, and keep the sign. okay? Because we're on the same side of the number line. Okay, so subtract 8, you're going to go back this way, gives you 16. So if they're the same sign, we're going to add those two digits because they're growing in either the left direction for the negatives, or they're growing in the positive direction if they're both positive. Okay, let's take a look at a solution to an equation. Okay, a solution to an equation is the number that replaces the variable to make the equation a true statement. Okay, so what we're going to do is evaluate this to see if we get a 10. So we're going to put the x right in there. So do we get a 10? On the left side, 16 minus 6, and 16 minus 6 is 10, so we get a true statement. And since that's true, then x equals 2 is a solution to the equation. Okay? So that's how we do that. Let's go ahead and go to the next page. And we have 10 here. And so again, we're going to evaluate with this -3 to see if we get a 10 here. So there. So the question is, are we going to get a 10 from this? So -3 in both spots. So that's positive 9 minus 6 plus 1. 9 minus 6 is 3, and 3 plus 1 is 4, so that is false. So x equals -3 is not a solution. Okay? Now let's take a look at number 12. This is a little different. It has a radical sign there. So this right here means square roots. Okay, so in other words, the answer is what times what, being the same exact number, is going to equal that number 64. And that's just going to be 8. So the square root of 64 we can simplify to 8. And then this is bring down the negative. Oops. Insert our -2 to see if we get 24. Okay. And so we have positive 16 right here. And then we have minus -2 to the third power is going to be a -8. And that's going to be plus plus now, which gives us positive 24. And positive 24 does not equal -24, so this is false. It's not a solution. Okay. Okay, so here's the answer key for the worksheet in your workbook, 6.1 worksheet number 1. All right, now we need to discuss combining like terms before we go into solving equations. So this is done often to simplify the left side of an equation and the right side of an equation, or one or the other, okay? And so there are two requirements for having like terms, and that's going to be the same variable and the same exponent. Okay. So a couple of examples to remind you what that means. Let's say we have x plus 3 minus 8x plus 12. And all we're saying is, okay, let's make this expression simpler by reducing the number of terms. So instead of having 4 terms, let's see if we can combine some of them into one term. So we see that we have x's right here. Those two can be combined to get negative 7x. And these two can be combined to get 15. Okay? So we've made this expression simpler by going from 4 terms to 2 terms. And that's definitely something you want to do if this is an equation and you're trying to solve it. All right, you make it simpler by combining like terms. Another way you can do this, if you don't want to mark it up like I just did, you can also group them together, if that helps. So here's another example. It's kind of long, but basically we can say, hey, this is too long. I want to organize this a little bit better so that I can see the like terms. So we can put the x terms together in a group. We can put the y terms together in a group. And we can put the constant terms together. Okay, so you're definitely more than welcome to group them so you can see that they're side by side. I prefer just to mark them up like this. Maybe put a box around these guys. Maybe put some underlines and whatever you want to do there. Okay, maybe you put 2, doesn't matter. Okay, so regardless of how you do it, the x's go together. And that's going to create a positive 1x. And then negative 5 plus 2y is negative 3y. And then 2 plus 10 is 12. So this is what we mean by combining like terms. So this big thing ended up being more expressed in a simpler fashion using 3 terms. Okay, so now we want to look at solving equations. And in class, I gave out a toolbox for solving equations handout. That's going to basically have all the different variety of tools that you can use to solve various types of linear equations. Okay, and I'll be mentioning them as we go along. So again, I'm going to do the evens. Okay. So here, there's nothing to simplify, all right? Everything is pretty much compact on the left side and the right side. What I mean by left side, I mean here's the left side of the equal sign, and here's the right side. So everything is simplified. So all we just need to do, is isolate the x, okay? Or whatever variable you're trying to solve. So isolate means get by itself. Or alone. Okay? So we're going to subtract 4 from both sides to keep the equation balanced. Okay, so 4 minus 4 is 0. That's why we did that. So we can go away from the left side. It's going to appear on the right side. So the algebra is keeping the equation balanced, and then the math is right there. So here's your math, and then this right here is the algebra. Okay, doing something to solve for x. So 25 minus 4 is 21. And then we want to do the inverse operation again to get rid of this negative 3 so we can get x by itself. So if we divide anything by itself, it's always going to be 1. And 1 is an invisible number next to these x's. So that's why we want to do that. Whatever I do to the left side, I do to the right side. So now my final answer then will be x equals negative 7. Okay, let's take a look at number 4. Okay, so here we have parentheses. So we want to clear those parentheses by distributing, okay? So we want to distribute the 3, and that'll clear those parentheses out. You don't have to rewrite those. Okay. And we basically have a simplified equation here now. We just need to get the variable isolated, okay? So we're going to add 15 to both sides. That's going to give us 30. And we divide both sides by 6. And that's going to give us 5. Okay? But the main thing we did here was get those parentheses out of our scenario. Okay, let's take a look at number 6. So in this case we have, as you can tell, we have a variable on both sides. And the sides, I'm talking about of the equal sign. Okay, so what do we do about variables on both sides? You can't solve it with 2 variables, one on each side. So we need to collect variables. This is in your handout. So it's already simplified on the left and the right, but we need to collect variables to one side. So it's better to choose the smaller of the 2 variables as far as their coefficients concerned, and that just keeps our equation or our variable term positive. You don't have to do it like this, but I like to use the smaller of the 2. Okay, then we finish this up by isolating. And we're done. Okay, so the main strategy here was to collect the variables to one side. There wasn't any simplifying, there weren't any parentheses, and so let's move on. Okay, so in number 8, we have a number of things we're going to be doing here. As you can see, if you observe before you start, we have variables on both sides. We have this, we have the parentheses here that we're going to have to take care of. We're going to have common terms on this left side because it's kind of big. And we're gonna have to combine the 5 with something, probably with this 5 right here. So there's a lot of things going on here. All right. So it's gonna take, this is a multi-step equation. It's gonna take us a while. So the first thing we need to do is, we see parentheses, clear them out. Okay, so distribute. Okay, so now we observe and say, wait a second. This right side is simplified, but over here on the left side, I can put those two together. So our second step is to combine like terms, CLT, on the left, because the right's already done. Okay, so 5 plus 25 is 30. And now we need to, as you can see, we have our variables on both sides here. So I'm going to collect my x's to the left. Whoops. Okay, because 2 is smaller, and if I subtract it here, it goes away. If I subtract it here, I get a positive x, and that's, I don't want to get a negative x. So this is going to be 8x plus 30, bring down everything, and here's our negative 5, who's still left on the right side. And now this is back to like number 2 that we did. So we're just isolating this x here. So let's get this 30 out of here. That gives me negative 35, divide by 8. And now we get negative 35 over 8. Okay, an improper fraction. So it is okay to have fractions, okay? Okay, or decimals in your answer. So don't freak out and think you did this wrong just because it does not divide evenly, okay? So this is perfectly fine. Okay, so why don't you try number 10 on your own? This is pretty much a good test question right here because it puts everything in one problem, a lot of the different techniques and tips. So go ahead and do this, and I will show you the solution in a few minutes. Okay, hopefully you have noticed that the left side equals the right side, and somewhere along the path you noticed that. So I'm showing you here in step 3 that negative 2x plus 21 is the same on the left and on the right. So right here we can notice something called an identity. So when you have the left side that matches the right side, we get something called an identity. Okay? And this is going to produce all real numbers. Okay? And again, an identity is just a true statement. Okay? So let's continue with this. You can notice it right here. Or if we continue by collecting x's to one side, and they're both going to cancel out. Giving us 21 equals 21. So there's another identity right there. Either way, gives us the same answer. Or if you want to keep going, we're going to get the same thing. Okay, so either way, any of those three green check marks are the points in which you can see the identity. Okay, so this is a true statement. Okay, so this brings us to how we did number 9 in class, where we got a false statement, and that was no solution. So we have the following scenario. If we get a true statement, that will produce all real numbers. And this scenario is called an identity. Okay? But our solution, our answer is right here. False statement and pretty much you'll see this when the x's cancel out. We have no solution, which this is called a contradiction. Okay? So please remember this as you're doing your work, as if you encounter this scenario. Okay, guys, we have reached number 12. And in number 12, we see some fractions. Now, some people look at fractions and they kind of freak out and say, I don't know what to do with this. Well, some may attempt to do common denominators, which is fine. But that way is actually dealing with the fractions, and I prefer not to deal with the fractions. And so one of the tools in your toolbox that I have listed there is to clear out the fractions, or basically the denominators, by multiplying all the terms by the LCM, the least common multiple. Okay, so that's what we're going to do here. Okay. So the strategy here is to clear out the fractions by multiplying all terms by the LCM. Okay, so what I mean by LCM is least common multiple. Okay, think of the multiples or the times tables, for example, for 5. 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15. Or in other words, we can just list them. So basically, you can figure out what the LCM is by looking at 5, 10, and 2, but I'm just going to do it the long way. And I'm going to list every number here from least to greatest. I'm going to say, okay, multiples of 2. 2, 4, 6, 8, 10, 12, 5, 10, 15, 20, 10, 20, 30. So you don't have to do it this way, but this is if you're not sure what the concept of least common multiple is. These are the multiples of the numbers 2, 5, and 10. And the L of the acronym means least, or the smallest, or the first set that all three have in common. And as you can see, it's 10 right there. Okay, so hopefully you can get to the point where you can just figure out that number in your head by thinking of 2 can be divided into itself, 2 can be divided into 10, and 5 can be divided into 10 as well. So every single number can be divided into 10, including 10 itself. So if I multiply all the terms, I'm just going to put a 10 next to every single term here. And what that does is creates a division problem. It creates a division problem with the denominators that were making this thing annoying. And so all you got to do is just divide these numbers right here. So basically in the first one we have 10 divided by 5 is 2. Okay, that's the new number that's created. The fraction is gone, but everything else is still involved. 10 divided by 10 is 1. And the 3 is still there. And then we have a 1. And then we have 10 divided by 2, which is 5. So basically what we just created is, and you can do this in your head as well, 4x plus 3 equals 5, which is much nicer than the 2x over 5 plus 3 over 10 equals 1 over 2. Okay, you're more than welcome to deal with those fractions, but here I just cleared out the fractions and now I just have a nice two-step equation here. And then divide by 4. So we get this fraction 2 over 4, which reduces to 1/2. Okay. So this is one way to deal with fractions. Okay. So I'm not going to do 13, but basically, if you don't deal with the fractions in number 13, even though this is odd, you're going to get this ugly mess. But you're going to have to actually okay, and it's just not very pretty here. Keep forgetting that X there. So 20 divided by 5 is 4. So at the beginning, we can take care of this problem by multiplying everything by 15. 15 is the LCM, or the LCD, some people call it. So we're going to put 15. That's one term there. And here's the other term right here. So basically this is going to create 15 divided by 3 is 5. 15 divided by 5 is 3. And then 3 times the 2, that's going to equal 6. Okay, so I don't know about you, but this side looks better than the ones with the fractions. Okay, so it's just something to think about. I hope you follow my advice to get rid of the fractions in the first step, but it's totally up to you how you want to do this. Let's take a look at our last problem. I don't have a 16, so we're just going to do this one. Now, with decimals, again, it can be kind of risky to try to deal with the decimals and keep them in. There's 3 decimals I got to keep track of, and it's not going to be fun because I can put the decimal in the wrong spot on the next line. I can forget about it or just miscalculate. I can type it in my calculator wrong. I mean, there's all kinds of stuff that can go wrong if you don't deal with the decimals now. So I would just rather clear them out. So in this case, we're going to multiply by 100. Now, why did I choose 100? That's because in this problem, the most decimal places is 2. Okay, so if you look here, I got 2 decimal places there, I got 1 decimal place there, and 2 there. So if I have, the most decimal places that I have to clear out happen to be 2 in this case, okay? So there's my 2 decimal places right there, 0, 0 from the 100. So basically, if we multiply by 100, in effect, that is moving the decimal 2 places to the right, 2 places to the right. In this case, I got to put a 0 and 2 places to the right. So now my new nice equation is just going to be 2 minus 40x equals 22. And I don't know about you, but I'd rather deal with those whole numbers than deal with a bunch of decimals everywhere and having to keep track of that. Especially if you don't have a calculator, that can be really annoying. So this is a nice, quick technique. Does not require the use of a calculator to deal with this problem. So we're going to go ahead and finish this up. Trying to isolate the x here, so we're going to subtract 2 from both sides. We're going to divide by negative 40. And that's going to reduce to 1/2. Okay. So this is the last problem for solving equations. So now what I want to do is use our techniques to actually solve a real world problem. Okay, something practical, something we do that we might use in an everyday life. Okay, so I want to go ahead and move on to worksheet number 3, which is 6.3 application of linear equations. Here are the answers for section 2, which is the equation part. Okay, and here is this 1 page of work that we're going to do in the next few minutes here. So first of all, we're going to practice translating. Okay. So the word more than, okay, it means to add 5. Okay, so more than 5 more than x means to add 5 to x, or you can put 5 plus x, doesn't matter. The sum is another addition. So the sum of what? The sum of 5 and x. Okay. The number 3, the number 5 decreased by what? So the number 5 decreased by x. Okay, then we have the product, which is times. So product of what? Well, the product of 5 and x, or we're going to just write 5x. 5 less than x. Now, be careful with this one. 5 minus x, that is incorrect. Okay, because 5 is being subtracted from x. Okay, you're taking the x and you're going to produce 5 less than that x. So in this case, it's in reverse. So we're going to put the x first and take 5 from that. So now that's 5 less than x, okay? The quotient is division, so we're going to use a fraction bar. So the quotient of x and 5, okay? Instead of x divided by 5, okay? This one's used more for solving equations and things like that. Okay, guys, I forgot to talk about number 65, which is another fraction problem. And this is an example from the textbook. So first of all, this answer key is 6.1 worksheet number 2, which has to do with the solving part. The first part had to do with simplifying and combining like terms, and evaluating, stuff like that, order of operations. So this is the solving part. So I want to take you to number 65. And I would like to do it 2 different ways, okay? So just to show you the difference between my LCM method and actually just not doing the LCM. So we'll see what the difference looks like. So first, let's do it by not doing the LCM. So in other words, I'm going to say, hey, I have like terms here. So this is a like term. I'm going to simplify that. But I have to do basically, that's 2 1/4, which I can convert that into, 4 times 2 is 8, 8 plus 1. So this is 9/4. Now another way you could have done that is by doing common denominator on the side here. So having to change this to a 4. So that's times 4. So yeah, I was right. So then you gotta get this whole 8 over 4, and the 8 plus 1 is the 9/4. Okay, either way, you're gonna get this here. Okay, so now some people pretty much get stuck right here because they don't know what to do with this fraction. And basically the trick is to remember, at least another shortcut is to do multiply by the reciprocal, okay? Because reciprocals like 4 over 9, if you multiply that, that's basically 36 over 36, which is 1. Or in other words, 4 divided by 4 is 1, 9 divided by 9 is 1. So we get our nice x here. But whatever I do to the left side, I must do to the right. So again, you have to deal with this, all these fraction techniques that you have to remember. Mixed numbers, common denominator, multiply by reciprocal. Now here I got to multiply fractions. So basically I got to get, I'm going to get 4 over 27. Okay, so let's see if you use my method. So you think of the LCM, and between 4 and 3 is 12. Okay, so now we just do 12 here, 12 here, and 12 here. So 12 divided by 4 is 3. 12 times 2, because that 2 is not in the bottom. Okay, there's actually a 1 there, right? So that's not going to divide, it's actually going to multiply. So that's just 24x. And then this right here, 12 divided by 3 is 4. And then I add these two up here because they're like terms. And I get, so notice the fractions are totally gone. Gives me 27x. And now divide both sides by 27. And as you can see, we get the same exact thing. Okay. So I will be putting this on your video check, and you can do either method, doesn't really matter. But I will say, please write down the question and answer for number 65 in the method of your preference, or something to that effect. Okay, so you don't have to copy both of these down for the answer, you just have to do one of them. So let's go to actually writing an equation. Okay, and we're going to skip the solving. Well, we'll see how it goes. Okay, we might do the last one. So a number decreased by 5. So a number is something we don't know. You can call it n or x or whatever you want. I'm just going to use n for number. So there's a number. It's being decreased by 5. And it says, so this is minus, all right, is, that's equals, okay? So is 10. So a number decreased by 5 equals 10. Number 8 is 16 increased by, that's plus. So 16 increased by what? Increased by 8 times a number. So that's 8n, 8 times a number. Is the equals 88. Okay, now you guys, we've done plenty of those. What about number 9? So number 9 says a number n divided by 3, okay, divided by 3, that's easy enough, is, okay, equals, now it's going to say 4 less than the number. So the same number, we got to subtract 4 from that. Okay, remember, you got to write it in reverse. Okay, so how would we solve this one if we have to solve number 9? Well, I can get rid of this 3. That's basically our annoying fraction, and we can say, well, let me multiply everything by 3. And that will take care of my fraction. It's going to clear that out. So that means this is going to be a 1. And this is going to be 3n minus 12 as we distribute. And then we want to move the variables to one side. And I'd rather choose, well, what I can do is I can move this 12 to the left. Okay, so we can kind of say, hey, negative 12. If I move it to the left side, when I cross that equal sign, and now he's positive. And if I move the n to the right, that's going to be 2n. Okay, and then that keeps our variable positive, which you don't have to do it this way if you don't want to. But then just by inspection, 2 times 6 is 12, so n equals 6. Okay, or divide both sides by 2. Okay, guys, so now we've reached the point of 6.3 where we are solving. We have to interpret, after we read the word problem, interpret it, translate it, and try to solve it, okay? Solving part is not going to be too bad. It's really the first stage, which is understanding the setup. Okay, so here we go. So on page 301, in your text, you have a nice general procedure to solve a word problem. So let's take a look at this. Okay, so first of all, read the problem carefully. All right, at least twice to be sure you understand it, okay? So you're looking for understanding the general scenario, okay? Now, if possible, draw a sketch because you want to visualize. So understand, visualize, and then once you understand and visualize, then you want to know, okay, well, what is it that I'm actually finding? Okay. What are you being asked to find? Choose a letter, X, Y, Z, doesn't really matter, for this unknown quantity. And then write down exactly what this letter represents. Do the equation part, solve it, and then you're not done after that. You need to answer the word problem. Okay? Because just by getting a number doesn't mean you answered it. You need to answer it in a sentence. Okay? So we'll come back to this as we do the first one here. Talks about Sam, who's working at Olive Garden. Okay, so the weekly salary. Okay, so this is not monthly, it's not daily, it's weekly. So that gives us the time frame and how much and where. Well, it's not really important where. He also receives a 6% portion or percentage of the tips collected for the week. Okay, so he's getting paid two different ways. And so this is part of the understanding. All right. So we have and then we see the word total here. So we have, okay, so what's my total weekly amount earned? Okay. Well, that's going to be a salary. That's weekly. In addition to that salary, you're going to get 6% of the tips. Okay, so this is how you can visualize what's going on. I'm getting paid. How am I getting paid? Two different ways. What are the two ways? I get a base of fixed amount. Okay, and then you get a percentage which can change. It could be, if you do, there's a lot of tips one week, you're gonna have more. You're gonna get paid more. If there's less tips, you're gonna get paid less. So that part is always gonna be variable, or just gonna change. So now the question is, here you see a goal. Okay, there's a goal here. I want a total. I want to, try to make $350 every week for whatever reason, and maybe it's to pay off bills or save up for a new car or whatever. Okay, and so we know totals have sums, and there's our sum right here. Okay, and those are the two things. So we just need to fill in the blanks here. So the goal for the weekly amount is $350. The salary from the word problem is $200. 6% needs to be translated into 0.06. Okay, it's not 0.6 because 0.6 is 60%. 0.06 of means time, so 6% of X, okay? Because we don't know the tips. We want to know what this is, okay? What must be the tips? So let X equal tips, or I can put weekly tips. Okay, so now we've set up our equation, then we just go ahead and solve it. So we're going to subtract 200 from both sides. Gives us 150. Divide both sides by 0.06. And we get x equals whatever this amount is. So we put that in our calculator and we get the number 2,500. So to answer this question, we say, okay, that number for x, now I'm going to translate it into a sentence. What must the tips be in order for Sam to make a total of 350 per week? Sam must have 2,500 in tips per week. Okay, that is the answer. Sam must have 2,500 in tips per week in order for him to reach his goal of 350 per week. Okay, let's take a look at number 11. So Hollister has a sale offering 10% off all jeans. If Amanda spent $207 on jeans before tax, what was the total purchase before the discount? All right. So what is going on here? We have somebody spending money, all right? But the amount that is paid is less than the original amount. How do I know that? Because there's a sale going on, and that sale is 10% off. Okay? What does that mean, off? Well, that means 10% off the original price. So when you're building your equation, actually when we visualize, we say, wait a second, we have the original price. Okay? She's not going to buy the original price. She's going to make sure she gets a discount, buys it when it's on sale. So the original price, you subtract whatever the discount is. So it's 10% off. So what they do at the register is subtract that sale off. So that is going to be 10% off. Okay. And that is what she's going to pay at the register. Okay, or the amount spent. Oops. And we have that right there. Okay. So what is the X? Well, we know the amount spent is 207. What we don't know is what the original price is. Okay, so let X equal the original price. And you can see it where the question mark is. What was the total purchase before the discount? That's the original price. Okay, so X, that means this is going to be X minus 0.10. And then off of what? It's 10% off of the original. So I got to put, so we're not going to subtract 10 cents, guys. If you don't put the X here, what you're doing is subtracting 10 cents. And that's not possible, okay? That doesn't make sense. It's 10% of the original price. So the original price, or the X, is repeated in this case. We have the original right here. And then 10% off the original. Okay, that's what they do at the register. Okay, so if let's say the jeans were $100, and you know that 10% of 100 is $10, so 100 minus 10 would equal 90. Okay, that's just a quick example. So this is what we don't know and we're trying to figure out, but we do know as a clue is that she spent $207. So now we have basically a 1x minus a 0.10. That's like saying $1 minus 10 cents is 90. So basically we have, if you combine like terms here, we have 90. And what this is basically saying is, if you have 10% off of something, you're going to pay 90% of the original. Okay? So actually you can do that part in your head, but we're going to just build it from here. And get 207 divided by 0.9 is going to be 230. Now 230 is not an answer. Okay. Yep. So the original price of the jeans before the discount is $230. Okay, it's a sentence. The original price of the jeans is $230. Okay, we got to get away from just throwing numbers and X's around and just saying that you're done. Okay, that's just the algebra that was used as a tool to figure out this real world problem. Okay, so let's take a look at number 12. This one's a little different. So we have Lauren and Brittany. Those are two people involved here. And we got the word together. Okay, that's like total. So Lauren and Brittany together plus receive 16 free iTunes songs for joining a music club. How many iTunes songs will each receive if Brittany is to have, now here's the clue that you have to translate, 3 times as many as Lauren. Okay, so let's put this in perspective here. Let's visualize. So remember, we have, we still don't have an actual picture, but we can visualize. Okay, we got 16 free songs, okay? And they're going to get, Lauren and Brittany are going to share that. So what we don't know, so we have Lauren plus Brittany together are going to receive 16 iTunes songs. Okay? So we have 2 variables. But here's the clue. Brittany, or the B, is to have, now here's the translation, 3 times as many as Lauren. So whatever Lauren has, Brittany's going to have 3 times as much. Okay, that's the clue that they wrote here. So we're going to use this clue to put this and replace it right over here. Okay, let me use a different color. So this B is going to replace by the 3L. You cannot solve an equation with one equation with 2 variables. So we need to get this thing replaced. So we're going to get L plus 3L. Okay, so this B is actually, so Brittany is actually the same as 3L. And now we have a nice simple equation that we're going to put together right there. That's 1L plus 3L is 4L. Divide both by 4. And we get 4. L equals 4. So what is this saying? Lauren will receive 4 songs. Brittany will receive 3 times as much. Okay, so remember, you're trying to equal 16, so this has to be 12. Okay, so this is the answer right there. Okay, so I want to do a few problems from the textbook that's in your homework. And I would like to do 17. So 3 times, we're going to translate this. 3 times, well, 3 times what? Here we have a quantity. Okay, and that quantity is the sum, which is plus a number and 7. So this is going to be 3 times the quantity n plus 7. Okay, so that's a little tricky. If you don't put the parentheses, it is incorrect. Okay, so be careful with that one. Number 27. A number increased by 6 equals 3 less than, remember that's reverse, so we got to write this first and then this second. So twice the number less than minus 3. Okay, so that one's a little tricky as well. A lot of stuff going on there. So again, a number increased by 6 is less than, it's minus. So twice the number, basically minus 3. Okay, you got to write this in reverse. Okay, I want to do some geometry questions. That's in your homework. And this is actually the ones we can actually draw some pictures. All right, and number 40 already has a picture. So let's take a look at number 39. So it says dimensions of a deck. Jin is building a rectangular deck, keyword, and wants the length to be 2 feet greater than the width. What will the dimensions be of the deck if the perimeter is 52? So another keyword there. So let's read it again. We know, first of all, it's rectangular. Okay, the deck is rectangular. And then he wants the length. So this is width over here. And this is length over here. He wants the length to be 2 feet greater than, that's a math word there, that's going to be plus, than the width. So whatever the width is, he wants this length to be, whatever the width is, plus 2. That's what 2 feet greater than the width means. Okay, so he's expressing the length in terms of the width, which is actually good. Now, the other word, perimeter, you should know that from geometry, perimeter is adding up all the sides. Okay, so we know this is also W, and this is also another L. Okay, so the definition of perimeter is adding up, is the total enclosure or adding up all the sides. So that's going to be L plus L because it's a rectangle and opposite sides are congruent. So basically the better formula is just 2L plus 2W. Okay, because we combine like terms right there. Now all we got to do is replace this formula with the things that we know. So what do we know? We know that the perimeter is 52 feet. So this P is a 52. And we also know that the L is a W plus 2. So this L now becomes W plus 2. And that's what we need, because we need everything to be in one variable. So we have 2 W's, which is good. And now we're going to solve this thing. So we're going to distribute. And then we're going to combine like terms right there. And now we're going to isolate the variable. And then we're going to divide by 4 here. So this is going to be 12. Okay, W equals 12. What will the dimensions of the deck be? All right, so what are these dimensions now? So we can say, hey, I just found the width, and we're going to need to find the length as well. So the width is going to be 12 what? Well, we've been using feet the whole time, so this is 12 feet. And the length is going to be, remember that it's 2 feet greater than the width. So if the width is 10, then the length is 12. In this case, it's 12, so this has to be 2 greater than this will be 14. Okay? Now we can actually check this out to see if it works. So basically, but you don't have to check. So we can say, okay, if I insert my 2 answers, am I going to get 52? So 14 for the length, 12 for the width. So 28 plus 24. 20 plus 24 is 52. So yes. Okay, it does check out. Okay, so the last one we're going to do is number 40. Enclosing 2 pens. Chuck has 140 feet of fencing. Okay, so that's how much of fencing he has laying around, or he went and bought it, in which he wants to fence in 2 connecting adjacent square pens with fencing between the 2 pens. What will be the dimensions if the length of the entire enclosed region is to be twice the width? Okay, so first of all, we know the total, okay? The total fencing. That includes this middle part here. Okay? So this time we have a total fencing. And that total is going to be made up of, now we have a length, and we know there's another length there, so we got 2 L's. Okay? And then the width, we have a width here and a width here, but it's not going to be 2L because there's another width right there. So we got 3 W's. Okay, so 2L plus 3W. All right. Now, what's the other clue here? right here, what will the dimension? The length, okay, so L is going to equal what? Twice the width. So twice the width. 2 times W. So all we're going to do is replace now the total and the L. So the total was 140. The L is 2W. Okay, and the other one stays the same. So now we have an equation we need to solve. That's 4W plus 3W, which is 7W. And then divide both sides. So we put those together. Divide by 7. And we get 20. Now, what will the dimensions be? So we need the width, we need the length, so the width, we just found it, 100 is 20 feet. And the length is twice as much, so that's 40. Okay, you say, wait a second, that doesn't equal 140. That's because, remember that our equation is right here. Okay, so basically, if we label this, this is 20, 20, 20. This is 40, this is 40. Okay, so 40 plus 40 is 80. Plus another 60 is 140. Okay, so this checks out. Alright guys, so sorry for making a super long video because it's 2 sections in one. So definitely make sure you have watched the entire thing and written down any notes that I've put down on the side for a video check. Alright, see you in the next video.